Thank you for choosing American Pest CEUs.
Hi, I'm Sean Reeves with American Pest CEUs. I've been in the pest management industry since 1999. I'm an associate certified entomologist, and I'll be your instructor for today's course. Today's course was compiled by Jack Launius, who has served in the pest management industry since 1990. Today's course is on vegetation control for rights of way. Why control vegetation, vegetation control options, and vegetation control programs. Enhancing safety for motorists and workers. Key objectives and benefits of vegetation management. Managing vegetation on rights of way involves strategic planning to meet multiple objectives. Roadside safety recovery zones. The safety recovery zone, also known as the clear zone, is essential for preventing severe accidents. When drivers inadvertently veer off the road, they need a space free from obstacles to regain control. This zone offers an area where they can stop or direct the vehicle safely. Roadside safety recovery zones. The width of the recovery zone is typically determined by the road's design, speed, traffic volume, and surrounding topography. Roads designed for higher speeds, like highways or those with high traffic density, require wider safety recovery zones to account for the greater momentum and risk involved when vehicles leave the road. Steeper slopes, like those seen with cut-and-fill construction, may also necessitate wider zones. On high-speed curves where vehicles are more likely to drift off sharply, wider recovery zones reduce the risk of fatal accidents, particularly by removing trees and other obstructions in these high-risk areas. The presence of vegetation, especially large trees in this zone, is a major cause, as collisions with trees are one of the leading causes of roadside fatalities. In response, many state and local transportation authorities regulate the allowable size of trees and shrubs in these zones to minimize collision risk. Utility and railroad safety hazards. In utility and railroad rights of way, worker safety is paramount. Thick vegetation obstructs visibility, creating hazards when crews need access for inspections or repairs. Clearing vegetation in these areas ensures that workers can access and maintain equipment with clear visibility and secure footing, enhancing both worker and operational safety. Preventing snow and ice hazards. In regions with harsh winters, vegetation can exacerbate hazards. Overhanging branches or dense roadside vegetation can interfere with snow removal and extend the time it takes for snow and ice to melt, making roads slippery and dangerous. Maintaining low vegetation levels helps control snowdrifts and minimizes accumulation on travel times. Enhancing visibility and signage. Maintaining sign visibility. Clear signage is essential for safe driving. Signs convey information, provide warnings, and guide motorists, especially in unfamiliar areas. Overgrown vegetation that obstructs signs can lead to accidents or driver confusion. Regular trimming of plants near signs ensures that they are visible at all times and helps drivers navigate safely. Improving sight distance on rural roads. Sight distance is essential for safe driving, as it allows motorists time to make informed decisions about passing, stopping, and merging, especially on two-lane rural roads where visibility is often reduced by hilly terrain or winding paths. Vegetation control is especially important on these roads where curves and intersections create natural blind spots. As speed increases, the required sight distance increases as well, making vegetation management critical in maintaining visibility. Vegetation blocking intersections or roadside curves can prevent drivers from seeing oncoming vehicles, pedestrians, or obstacles. By regularly trimming vegetation in high-risk areas, road agencies help maintain safe sight distances, allowing drivers to see potential hazards and make necessary maneuvers well in advance. Preventing hazardous overgrowth on shoulders. Overgrown vegetation along the shoulders of roads can cause various hazards, especially on narrow, two-lane highways. Tall grasses or shrubs can obscure the shoulder, narrowing the roadway and potentially forcing drivers toward the center of the road, increasing the risk of head-on collisions. Vegetation growth along shoulders also encourages a phenomenon known as road narrowing, where drivers feel psychologically pushed towards the middle of the road, often resulting in unsafe passing and erratic lane positioning. Furthermore, some drivers struggle with depth perception on the vehicle's right side, which can cause them to veer toward the center when the shoulder vegetation is dense. By keeping roadside shoulders clear, agencies create a safer, more defined driving space, improving the flow of traffic and reducing the chance of erratic driving behavior. Ensuring proper drainage and road longevity. Drainage management on road shoulders. Vegetation can impede drainage by blocking water flow in ditches and along shoulders, leading to dangerous puddles or ice patches. Without proper drainage, water on road surfaces can cause vehicles to hydroplane, while pooled water can weaken the road structures. Controlling vegetation ensures water flows freely away from roadways, helping to prevent accidents and preserve road integrity. Erosion and surface degradation. Uncontrolled vegetation can cause significant damage to road surfaces. Plants that take root in cracks can exacerbate these gaps, allowing water infiltration and accelerating deterioration. Roots, especially those from hardy weeds and plants with spreading rhizomes, penetrate pavement and accelerate cracking, which weakens road structures over time. Water pooling in these cracks during rain or freeze-thaw cycles in colder climates can further expand the damage. Shaded areas where moisture lingers longer are particularly prone to this issue. By removing vegetation regularly, especially along paved shoulders, agencies prevent structural degradation, extend the lifespan of road structures, and reduce costly repairs over time. Snowdrift control and debris management. In winter, dense vegetation can lead to snowdrifts by blocking wind flow, which would otherwise disperse snow. Snow buildup can be hazardous and costly to clear. Controlling vegetation near roadsides reduces snow accumulation, lowering both maintenance expenses and accident risk. Fire hazard reduction. Fire hazard reduction, reducing flammable vegetation in fire-prone areas. In fire-prone regions, vegetation management is especially crucial for preventing wildfires. Dry vegetation, such as grasses or shrubs, can ignite easily from sparks or heat sources, such as hot vehicle parts. Rights-of-way often include areas with highly flammable plant species, like dry annual grasses, common in the western U.S., which become tender during droughts. How many of you have been driving down a road, you're just driving, cruising along, and you notice that the weeds and brush are growing too close to the road? I can tell you I've seen that all throughout the country, especially more in rural areas, although I've seen it in some urban cities, especially ones where we've really let them decay. But the reality is there's some major issues that can happen with this. Now, we talked about the damage it can do to roads and the obstructions for drivers, but also the fire hazard's a really big deal. So especially in areas that are drought prone out west, we need to really think about the fact that this type of brush and debris growing right next to the road is going to be a huge issue and can lead to fires. And when you have fires on roadways, those of you that have not dealt with them or driven through them, it's a really big deal. It can shut down traffic, it can stop visibility. It's just not something we want to deal with. So right of way is a very important thing, and controlling this vegetation can actually save lives. Regular removal of such vegetation in roadside and utility areas helps create fire breaks, limiting the spread of wildfires and offering access points for firefighting efforts. In utility corridors, vegetation that touches or grows close to power lines poses a serious fire risk, as arcing electricity can ignite dry branches. By clearing fire-prone vegetation, agencies mitigate the risk of fires igniting along these corridors, protecting both the infrastructure and nearby communities. You know, guys, I can tell you when it comes to wildfires, they're really a big deal. Here I'm on fire.ca.gov. This is a California government wildfire website, and they talk about wildfires. They even have a live map kind of showing you where active burns are. But the reality is, when you look at these numbers, it's unbelievable the number of acres burned just in a state like California. I'm picking out California because that's where I hear about the most wildfires. Obviously, you got a lot of droughts out that way. It doesn't rain a lot. Got a lot of wind. But the reality is, again, with rights of way, this is why it's so important that we don't have that brush and those weeds growing close to the roads, because it just leads to more and more of these wildfire situations. And also, making sure that the brush and debris is trimmed back from the roads really helps firefighters. If you think about it, if there's a highway that's already going to be concrete, and then the brush and weeds are trimmed back, this is a nice little break for the fire where it can't just come across as easily. So this can really help them in their firefighting efforts, as well as we talked about, just protect the roads and the drivers themselves. So just keep in mind, the reason why we're talking so much about these wildfires, they are a really big deal, and we need to do our part to help prevent them. Maintaining fire breaks for utility safety. Electric utility rights of way often require strict vegetation management to prevent trees from contacting power lines, which can spark fires. Fire breaks, cleared areas around power lines and substations, act as barriers, preventing the spread of fires and allowing firefighters access to these critical areas during emergencies. Fire prevention in utility zones is especially important to prevent fires from affecting populated areas nearby. Minimizing environmental impacts. Preventing soil erosion and sediment runoff. Rights of way often border water bodies where erosion and runoff can lead to pollution. Grass or low-growing native plants act as biofilters, trapping sediment and allowing water to flow freely, preventing erosion from washing soil and pollutants into streams or rivers. Protecting local wildlife and ecosystems. Vegetation management practices can support local wildlife and ecosystems by preserving native plant species and preventing the spread of invasive species. Managing rights of way with a focus on biodiversity allows these areas to serve as ecological corridors, supporting a range of species while minimizing negative impacts on the ecosystem. Certain management practices like selective clearing and establishing native vegetation promote habitat conservation. This approach balances infrastructure maintenance with environmental stewardship, ensuring that rights of way contribute positively to the surrounding ecosystem. Controlling noxious and invasive species. State laws often mandate the control of invasive or noxious weeds, which can damage crops, ecosystems, or public health. These plants can quickly dominate areas and disrupt natural ecosystems. Vegetation managers are responsible for identifying and removing noxious species, protecting agricultural interests, and preserving native ecosystems. Infrastructure and equipment maintenance. Preventing vegetation encroachment on equipment. When vegetation encroaches on infrastructure like utility poles, substations, or railway equipment, it can obstruct inspections, create access issues, and accelerate equipment wear. Dense vegetation around equipment retains moisture, which can corrode metal components decreasing the lifespan of the equipment and leading to more frequent repairs. This is especially problematic for electrical equipment, where moisture retention around cables or substations increases the risk of short circuits and electrical fires. Regularly cleaning vegetation around these areas allows for easier maintenance and helps to reduce equipment deterioration caused by environmental factors. Ensuring access for inspection and repairs. Railroads, utilities, and pipelines require clear access for routine and emergency inspections. Dense growth along rail lines or around utility poles can obstruct visibility, making it difficult for inspectors to spot potential problems. Clearing these areas ensures fast, safe access for repair and maintenance crews. Cost savings from proactive vegetation management. Reducing repair and maintenance cost. By proactively managing vegetation, agencies minimize damage to infrastructure and lower maintenance cost. Regularly trimming hazardous trees near power lines reduces the chance of costly emergency repairs. Similarly, well-managed vegetation along roadsides prevents surface degradation, reducing the need for frequent repaving. Extending infrastructure lifespan. Proactive vegetation management is essential for preserving the functionality and longevity of infrastructure. By controlling plant growth around roads, railroads, and utility lines, agencies prevent damage from root intrusion, reduce corrosion risk, and maintain clear access for routine maintenance. For instance, trimming vegetation around drainage systems prevents sediment buildup, which can lead to blockages and erosion if left unmanaged. Regular clearing also reduces the risk of fire damage in fire-prone areas, particularly for electrical and pipeline infrastructure. By extending the lifespan of infrastructure through vegetation control, agencies not only save on repair costs, but also ensure that these structures continue to operate safely and efficiently. Roadside rights-of-way. Roadside areas are managed primarily to enhance motorist safety and maintain road functionality. Safety recovery zones and clear shoulders ensure a safe space for vehicles that veer off the road and provide clear sight distances for safe driving. Regularly trimmed vegetation along ditches and shoulders improves drainage, which prevents erosion and water buildup that can lead to dangerous road conditions. In winter, keeping shoulders clear helps control snowdrift and reduces the likelihood of snow accumulation on the road. Roadside vegetation control also enhances aesthetics, creating an orderly and visually appealing landscape for travelers while supporting native plants that stabilize the soil and prevent erosion. Utility and railroad safety hazards. In the case of utility and railroad rights-of-way, vegetation management is vital for safety. Dense vegetation can create hazards by blocking visibility or access for utility and railroad workers, slowing down emergency responses or routine maintenance. For utility lines, overgrown trees pose a risk of electrical contact, which can lead to electrocution, fires, or power outages. Vegetation encroaching upon power lines is especially dangerous during storms, as strong winds can snap branches and lead to downed lines, which are a major hazard for the public and utility workers alike. Electrical utility rights-of-way. For electric utilities, vegetation management is essential to prevent outages, fires, and accidents. Trees and tall vegetation near power lines can lead to power interruptions and fire hazards. Maintaining adequate clearance between conductors and vegetation reduces the risk of arcing, a situation where electrical discharge can occur, posing a fire hazard. In addition to this, keeping vegetation clear around substations and storage areas reduces fire risk, prevents equipment corrosion, and ensures accessibility for emergency crews during power outages or storms. Frequent inspection and maintenance are crucial for preventing overgrown plants from interfering with power lines, poles, or other utility structures. Along railroad lines, vegetation growing too close to tracks can cause problems with visibility for train engineers, particularly around curves and crossings. Clear sight lines along tracks and at road crossings allow operators to see potential obstructions and hazards on the rails. Maintaining vegetation-free areas along utility and railroad lines enables safe and efficient maintenance, reduces fire risk, and protects workers by ensuring clear paths and visibility. Pipeline rights-of-way. Pipeline rights-of-way require clear access for inspections and repairs, and vegetation control is crucial in preventing root intrusion, which could damage pipes and lead to leaks. By keeping pipelines clear of dense vegetation, agencies allow inspectors to detect leaks, corrosion, and other potential issues that may compromise the safety and integrity of the pipeline. Pipeline corridors, often running through remote or natural areas, can also support native vegetation selectively, balancing environmental goals with infrastructure protection. Additionally, maintaining fire breaks near pumping stations and storage areas reduces fire risk, and these clear zones enable quick access for maintenance or emergency repairs. Vegetation control options. Managing vegetation and rights-of-way requires a strategic approach to control unwanted weed species and support the growth of desirable plants. Various vegetation control methods can either stress unwanted vegetation or create favorable conditions for desired plants. These methods include biological, cultural, preventative, manual, mechanical, and chemical controls. Often, no single method proves universally effective, so comprehensive vegetation management programs rely on an integrated approach. Combining multiple methods allows managers to ensure safe and reliable rights-of-way while optimizing costs. How can the use of beneficial insects help in weed management? Biological control leverages living organisms such as insects, animals, or plant pathogens to manage unwanted vegetation. These organisms are introduced specifically to target certain plant species. For example, state and federal agencies may release insects or animals that naturally regulate weed populations over the long term. As shown in the image on the bottom right here, the musk thistle headweevil is an example of a biological control. Although biological control methods are relatively inexpensive to maintain, they usually show slow results as they require time for the organism populations to establish and grow. Additionally, biological controls are typically weed-specific, making them suitable mainly for regional programs targeting particular weed types, with rights-of-way as secondary beneficiaries. While biological controls may not eradicate weeds completely, they can effectively reduce the spread and impact. Animal control. Goats, for example, may graze in areas challenging for large equipment to access, while specific insects, like those that burrow into seed heads or feed on plant roots, are used to control weeds like musk, thistle, purple, loosestrife, and leafy spurge. Over time, these insects multiply, helping to curb weed population in rights-of-way. Cultural controls. Cultural controls focus on preventing weed establishment through early intervention and indirect management strategies. One effective technique involves planting native vegetation, such as wildflowers and perennial grasses, to create competition for resources like nutrients, water, and sunlight, which limits the space for unwanted species. Allothropy, a natural phenomenon where certain plants Release chemicals that inhibit the growth of neighboring species also plays a role in cultural control. Plant selection tailored to specific site conditions is essential. For instance, drought-resistant or salt-tolerant grasses may be planted along highways, subject to winter salting, and native wildflowers provide visual appeal while slowing weed invasions. Other cultural control methods, such as strategic timing of treatments, adjusting cutting heights, and using fertilizers, lime, or mulch, promote the development of desirable vegetation without chemical or mechanical intervention. Liming, for example, reduces soil acidity, preventing the establishment of certain weeds, while mulching helps retain soil moisture and suppress weeds. In some cases, control fire can encourage the growth of desired vegetation, like prairie plants, but fire management on rights-of-way is often restricted due to smoke hazards and local fire regulations. Cultural control methods thus combine plant selections with environmental modifications to sustain native plant communities and minimize weed intrusion. Manual controls. Manual control methods utilize hand-operated tools to manage vegetation, offering a highly selective approach to weed management. This technique includes the use of equipment such as string trimmers, chainsaws, brush hooks, machetes, hoes, and shovels. Manual control is particularly advantageous in areas where mechanical methods may be impractical or too invasive, such as sites with sensitive ecosystems, steep terrains, or close to valuable infrastructure. When employing manual controls, operators must prioritize safety due to the inherent risk associated with using sharp tools. Personal protective equipment, PPE, is essential and typically includes safety goggles, gloves, ear protection, long sleeves, and sturdy footwear to safeguard against injuries. Additionally, operators face increased exposure to road traffic and the potential for trips and falls on uneven ground, which necessitates careful attention to surroundings and working conditions. While manual control is often labor-intensive and time-consuming, it allows for greater precision in targeting specific weeds, thereby minimizing collateral damage to desirable plant species. For instance, using a chainsaw to selectively cut unwanted trees can prevent the disruption that might occur if a large mower were to indiscriminately clear an area. Moreover, manual control methods can be beneficial in maintaining aesthetic values along rights-of-way. Regular hand maintenance can keep areas tidy, reducing the visual impact of vegetation while simultaneously controlling weed populations. However, one drawback of manual control is that cut vegetation often requires removal from the site, adding to labor costs and efforts. Furthermore, many perennial plants have the potential to resprout after being cut, necessitating multiple treatments and ongoing management efforts. Overall, while manual controls may not offer a permanent solution to weed problems, they serve as a vital component in a comprehensive vegetation management strategy, especially when other methods cannot be used effectively. Mechanical controls. Mechanical controls involve the use of machines and equipment to manage and suppress weed growth effectively. Mowers are the most common form of mechanical control utilized in rights-of-way management. These machines are designed to cut above-ground vegetation without damaging the root systems, which can lead to increased regrowth of certain plants, particularly perennial species. While mowing is an effective means of preventing the flowering and seeding of annual or biennial weeds, it requires careful management to avoid potential negative consequences. One of the critical considerations with mechanical controls is the potential for erosion. When grasses are cut too short, it can create an open soil structure that is susceptible to erosion by wind and water. Additionally, close cutting practices can encourage the invasion of broadleaf weeds, leading to a shift in plant community dynamics that may favor undesirable species. Moreover, if the cut material is not properly managed, it can smother desirable grasses, create fire hazards, or obstruct drainage systems during heavy rains, compounding maintenance challenges. In terms of equipment, mechanical controls encompass a range of cutting implements, including rotary mowers, flail mowers, and sickle bar mowers. The choice of mower depends on the specific application and the scale of the operation. For example, small mowers may be used for two-lane local and county roads, while larger machines with cutting widths of 12 to 24 feet are employed for high-traffic interstate highways. Different types of cutting heads can also be utilized, each suited for specific vegetation types and mowing conditions. Beyond mowing, other mechanical methods may include the use of brush cutters or specialized machines like Hydro-Axe and Kershaw, which are designed to handle heavier, denser vegetation. These machines can effectively clear brush and shrubs, maintaining rights-of-way and preventing encroachment into roadways or utility lines. Innovative mechanical techniques, such as the application of geotextile mats or polymer barriers, are also gaining popularity. These materials can prevent weed growth by suppressing sunlight and disrupting the soil environment, providing a temporary solution to weed infestations. However, such methods are generally not suitable for extensive clearing operations and should be viewed as supplementary to broader mechanical strategies. Chemical controls. Chemical control methods represent a powerful approach to vegetation management, utilizing herbicides and plant growth regulators to selectively target and manage weed populations. This method involves careful planning and application, requiring knowledge of various herbicides, their mechanisms of action, and their specific effectiveness against different weeds. The selection of herbicides is critical and often involves assessing the spectrum of control offered by each chemical. Some herbicides are designed to target specific weed species, while others may have broader applications. This specificity allows managers to choose herbicides that effectively control undesirable plants without adversely affecting desirable vegetation nearby. Additionally, the timing and method of application play crucial roles in the efficacy of chemical control. For instance, applying herbicides at the correct growth stage of the target weed can significantly improve control success. Herbicides can provide both short-term and long-term management options, with some formulations designed to suppress growth for extended periods. Certain pre-emergent herbicides, for example, can prevent weed seed germination, effectively reducing weed populations before they establish. Post-emergent herbicides, on the other hand, work by targeting actively growing weeds, which can be particularly effective during periods of rapid plant growth. Despite the advantages of chemical controls, they are not without challenges. The potential for off-target damage to desirable plants is a significant concern, necessitating precise application techniques and equipment calibration. Proper training for applicators is essential to minimize risk and ensure compliance with local regulations regarding herbicide use. Additionally, there are growing concerns about the environmental impacts of chemical applications, including potential effects on non-target organisms, water quality, and soil health. Integrating chemical controls into a broader vegetation management program allows for a more comprehensive strategy that balances effectiveness with environmental stewardship. By utilizing chemical methods alongside manual, mechanical, and cultural controls, managers can develop a holistic approach that optimizes weed management while minimizing negative impacts on the surrounding ecosystem. In summary, while chemical controls offer many benefits for managing vegetation and rights of way, they require careful consideration and implementation within a broader, integrated pest management strategy to achieve suitable outcomes. Right-of-way vegetation management is essential for public safety and infrastructure reliability. Because each control method has unique advantages and limitations, no single technique can address all vegetation management needs. Instead, an integrated approach combining multiple control strategies ensures the most effective and economical outcomes with minimal environmental impact. Vegetation Management Overview. A vegetation management program may be categorized as either non-selective or selective. Non-selective management entails the control of all types of vegetation, whereas selective management allows for certain plants to remain following treatment. Both approaches are essential in the context of managing vegetation along rights of way. Certain techniques can offer a mix of both non-selective and selective management based on specific circumstances. For instance, fire is generally perceived as a non-selective method since it impacts all vegetation. However, it can selectively regulate plant growth, as perennial species may re-sprout while annual plants may not. Similarly, mechanical control methods such as mowing can also be non-selective when all vegetation is cut down, but they can be selective if they permit the regrowth of perennial plants or leave shorter, uncut plants to thrive. Non-selective vegetation control programs. In the realm of herbicides and plant growth regulators, non-selective vegetation control often signifies the chemical management of all plant life. These treatments typically result in periods of bare ground, which can be transient or persist throughout the growing season, influenced by both the types of plants present and the herbicides utilized. Non-selective control can be achieved through various methods. After the emergence of weeds, total control can be achieved with non-selective, post-emergence herbicides that lack residual activity in the soil. If rainfall is frequent throughout the growing season, this control may be short-lived, allowing new plants to establish shortly after treatment. Conversely, if conditions remain dry post-treatment, bare ground can persist despite the absence of residual soil activity. Complete control can also be accomplished with soil-active herbicides applied prior to weed emergence. These herbicides rely on rain to infiltrate the upper soil layers where weed seeds are poised to germinate. For optimal effectiveness, applications should be conducted before weeds sprout and ideally coincide with an expected rainfall that will aid in herbicide absorption into the soil. In many regions of the U.S., early spring is the preferred application time, while in drier areas, treatments may occur during the fall or winter to leverage winter precipitation. For areas with existing weeds, combining non-selective herbicides which are absorbed through the leaves with those exhibiting residual soil activity can facilitate total control. Total control may also be achieved through the use of non-selective herbicides that are absorbed by both the roots and foliage and possess residual soil activity. Since no single herbicide can manage all plant types, tank mixing different herbicides becomes a crucial strategy for effective non-selective weed control. The choice of herbicide or combination is affected by site conditions, the species of weeds present, herbicide cost, available equipment, climate factors, and the desired duration of weed control. Guide rails. Guide rails serve to keep vehicles from leaving the road where recovery space is limited, as well as to provide motorists with visual cues. To maintain visibility and facilitate inspections by maintenance personnel, it is crucial to control weeds around these rails. Vegetation can cause moisture retention, leading to rust on the rails. Guide rails are typically installed in asphalt, gravel, or grassy areas, and materials like aggregates and winter abrasives can collect beneath them, increasing moisture retention and promoting weed growth. Weeds can also infiltrate the spaces around guide rail support posts fixed in asphalt. Weed control in these areas generally employs chemical and/or manual methods. When guide rails are secured in asphalt, addressing cracks and crevices is vital for effective weed control. Various techniques can be utilized for treating guide rails, such as handgun sprayers, short booms with nozzles targeting each side, flood nozzles, or off-center nozzles treating the front and underside of the rails. While mowing is straightforward in front of guide rails, the rear can be more challenging. Median barriers. Median barriers help prevent traffic from encroaching into opposing lanes and, like guide rails, often gather aggregates and abrasives that foster weed growth. Weeds are generally controlled through manual methods or herbicide applications using a variety of techniques, including handguns and off-center or straight stream nozzles. Treatments are typically spot applications. Given the minimal soil present and the potential for excessive surface runoff, care should be taken when using herbicides with residual soil activity. Signposts and delineators. Similar to guide rails, signposts and delineators are embedded in soil or asphalt and are susceptible to rust due to surrounding weeds. Mowing around these structures is typically not feasible. When anchored in asphalt, treatment of the base, cracks, and crevices is essential. Non-selective herbicides are usually applied around the posts to facilitate more efficient mowing. Fences. Weed management around fences can be complicated due to the difficulty of mowing in those areas. The optimal approach is to apply a banded residual weed control treatment, although care must be taken to avoid harming nearby trees whose roots might absorb residual herbicides. When using such herbicides near trees, it is crucial to read the label to ensure safety for desirable species. In many cases, applying herbicides without residual soil activity may be the safer option. Weeds near fences are typically treated using handgun or backpack sprayers. Structures, abutments, headwalls, and inlets. Vegetation around abutments and headwalls can hinder maintenance and cause issues with drainage visibility. Weeds around drain inlets must be managed to maintain proper drainage functionality. Herbicides are commonly applied using handguns or backpack sprayers, with caution taken to avoid spraying directly into the drainage system. Storage yards. Effective weed control in storage yards is essential for safety, aiding workers in locating parts and supplies, and minimizing equipment deterioration. Mowing can be challenging due to obstructions, making herbicide applications a preferred method of control. If space allows, a combination of broadcast herbicide application and handheld equipment can be used for hard-to-reach areas. Granular and pelleted herbicide formulations are convenient options in storage yards. Road shoulders. Total vegetation management along road shoulders prevents weed growth that can deteriorate asphalt and creates a clear stopping area for motorists, reducing fire risk. Weeds can destabilize the soil, while a weed-free shoulder maintains compactness for safer vehicle movement and reduces erosion. Non-selective herbicide treatments are recommended to keep shoulders clear without disturbing the surface typically applied from a moving vehicle outfitted for this task. Curbs, gutters, and median islands. When we look at curbs, gutters, and median islands, they feature diverse materials such as soil, concrete, asphalt, gravel, and brick. Non-soil surfaces often have cracks that enable weed growth, which can attract litter and pests. Residual soil-active herbicides are used to treat these areas to suppress weeds, generally applied using a backpack or a handgun. Ditches. Roadside ditches may be kept clear of weeds to ensure swift water drainage after storms. Vegetation can impede water flow and trap soil, leading to accumulation that must be removed to maintain ditch functionality. Residual, slow-active herbicides are often applied along these ditches during dry periods with careful selection of herbicides based on water usage after leaving the right-of-way. Railroad bridges. To prevent vegetation around the wooden supports of railroad bridges, residual soil-active herbicides are applied early in the growing season. Treatment can be conducted manually with granular spreaders or through specialized equipment like bridge booms on high rail trucks. These booms feature clustered off-center nozzles that spray in opposing directions and can be adjusted for height. A buffer strip must be maintained before and after any water bodies in accordance with label guidelines. Railroad yards. To maintain long-term vegetation control, residual soil-active herbicides are used early in the growing season around rail yards, switches, buildings, and storage spaces. Typically a fixed boom sprayer with a flat fan or off-center nozzle is mounted on high rail trucks or rail cars for application. Handheld spray guns are also utilized for treating inaccessible areas near buildings. Line of road. In railroad vegetation management, the line of road phase focuses on controlling vegetation along main and branch lines, as well as around signs and other trackside features. This usually requires post-emergence treatments for immediate weed control. Weeds are often present at the time of application, and new growth may begin before the first frost. Similar equipment used for yard treatment is employed, such as high rail trucks or spray trains with fixed booms and off-center nozzles. Substations and pumping stations. Consistent vegetation management is critical in substations and pumping stations to minimize fire risk and maintain operational reliability. Handgun applications are predominantly used around these facilities. For areas with considerable open space, short booms mounted on light trucks or ATVs are effective. Selective vegetation control programs. Many roadside management practices incorporate selective herbicides that target broadleaf weeds while allowing desirable grasses to flourish. Non-selective herbicides or targeted applications are reserved for particular problem areas or specific weed species. Broadleaf weeds. Tall broadleaf weeds can detract from the roadside's appearance, making their control a primary objective of many vegetation management strategies. Traditionally, growth regulator herbicides were utilized for this purpose. Broadleaf weeds. However, the availability of a broader range of herbicides has improved weed management, allowing for selective control of broadleaf species without harming grasses throughout the growing season. Early spring applications, when weeds are small and obscured by grass, may yield less noticeable results, while fall treatments effectively manage germinating winter annuals and biennials. Broadleaf herbicides can be combined with growth regulators to inhibit grass seedhead development in one application, with application methods including spot or broadcast treatments via various spraying equipment. Attention to drift is crucial due to the potential for adjacent sensitive crops. The extensive areas typically treated, and the proximity of roadside traffic to application sites. Ditches. In the U.S., drainage ditches are often managed to promote grass cover while eliminating aggressive broadleaf weeds. These treatments aim to protect ditches from erosion caused by rapid water flow. Kudzu is a classic example of good intentions that resulted in bad outcomes. Kudzu is particularly common in the southeastern United States. Landowners know all too well that kudzu can stifle agricultural production as well as timber growth. It often becomes a weed in non-cropland areas such as rights-of-way, old fields, vacant lots, or yards of abandoned or little-used buildings. Now this is an invasive species I can attest to firsthand. When I was a kid in Tennessee, I would see kudzu growing everywhere. It would literally overtake whole forested areas, whole rights of way. You just look on the side of the road and you'd see nothing but a green sea of kudzu. It was really impressive what it was doing. Now when I was younger, I didn't realize what was going on. I didn't realize it had actually been planted by the government. But I could even see as a kid, like it was overtaking telephone poles, road signs. It was just unbelievable how this stuff was just so invasive and just taking over everything. Kudzu arrived in the U.S., like other marvels, via World's Fair. Native to Japan, it debuted in North America at the Philadelphia Centennial Exposition in 1876 and was introduced into the South in 1883 at the New Orleans Exposition. Farmers soon showed interest in the plant as an alternative feed for livestock and a means of mitigating erosion. So basically what we're looking at this plant as, it was used on rights of way to mitigate erosion, especially like embankments and things like that will wash out. They thought with the roots and how dense and thick this plant was that it would keep those areas from washing out. To control kudzu in rights of way, you can use the following methods: chemical control, aminocyclopyrachlor, aminopyrrolid, clopyrrolid, metsofluron, and picloram products are highly effective for kudzu control on non-crop and rights of way areas. When we look at mechanical control for kudzu, we dig out the crown, a bulb-like feature at the top of the root system that holds all the energy of the vine to make the vine die. Also with mechanical control, for small patches in newly infested areas, hand pulling and digging out the root crowns can help. Lastly, when we're looking at mechanical control for larger areas overtaken by kudzu, goats are a great option. On this slide, we're looking at invasive species management. Invasive species pose significant challenges in vegetation management. Look, as you can see here, arundo. This chokes riversides and stream channels, interferes with flood control, crowds out native plants. It ignites easily and can cause intense fires. It grows vertically without any horizontal branching and does not provide shading to the in-stream habitat, which can lead to increased water temperatures and reduced habitat quality for fish and other aquatic wildlife. This is the Sepulveda Basin near Lake Balboa in LA. This brush fire literally burned out of control. One of the things that was a big fuel for this fire was the arundo weed, which we just talked about was an invasive species. This was a really big deal. We got this invasive species that just happens to be really flammable and ignites easily. Next thing we know, we got a wildfire out of control. So you do need to study and understand invasive species, because if you don't, you're not going to understand how these types of things take place. This photo is courtesy of Fox. This is the same vicinity the fire was in. So as you can see, the arundo weed was there. It burned up, everything burned out. What happens next? We have a situation like this where the arundo weed choked out the waterway, causing the floodwater to overflow into nearby streets. You can see the homes underwater. This flood caused millions of dollars in damage. So once again, these right-of-way services and things we're looking at, it's a really big deal. In this case, you see the worst case scenario where something gets out of control and results in millions of dollars in damage. Effective invasive plant management often involves a combination of strategies including monitoring, regular assessments help identify invasive species and their extent, mechanical control. Methods such as cutting or mowing can be used, although they may require multiple applications. Herbicide application. The selective application of herbicides can help manage invasives while protecting native species. Effective vegetation management along roadways and railroads requires a multifaceted approach, combining non-selective and selective control methods tailored to specific circumstances, understanding the dynamics of invasive species, the challenges of various sites, and the appropriate use of herbicides and mechanical techniques is critical for maintaining safe and functional transportation corridors while promoting ecological health.
Congratulations, you have completed the course. Please proceed to the 20-question quiz. Please drop us a line and give us your comments on the course, pestceus@gmail.com.